Hey guys, we are looking at chapter 4 and we're looking at section 4.1, the distributive property. Distributive property is a pretty important property in algebra. You're going to see it a lot. So make sure you feel really comfortable with what we're talking about and what we're doing. All right, so our vocabulary, we've got two terms for our vocabulary. The first one is equivalent expression, and that's an expressions or expressions that have the same value. So for instance, I could say, let me actually get a marker here. I could say that 2 plus 3 is the same as 4 plus 1. These are two expressions and they're equivalent. If I were to tell you that x plus 5 is equal to 7, I could say that these are two equivalent expressions and you would get some idea of what x is equal to. So equivalent expressions are used all throughout algebra, and one place that we're going to talk about equivalent expressions is in relationship to a distributive property. So what the distributive property does, I'll write it a little bit larger, A times the quantity of B plus C. So if I have A and I'm multiplying it by this sum, I can also write the same thing as A times B plus A times C. And we can test it out. So if I had 4 times, let's say 2 plus 1, we know, and I'll use a little bit of a smaller marker or smaller pen, we know that's just 4 times 3, correct? We use black. We know that's just 4 times 3, which we know to be 12. However, this distributive property tells me that I can write it as 4 times 2 plus 4 times 1. Notice I'm multiplying A, in this case, times each of these terms in here, and as I did, I multiplied the 4 times each of these terms in here. 4 times 2 is 8, and 4 times 1 is 4, and 8 plus 4 is 12, right? And I'm sure what you're thinking is, well, why on earth would we do that? Well, you would do that when you are unable to actually add the 2 plus 3. So in a case like this, 2 plus 3, I'm going to add the 2 plus 1. I'm going to add the 2 plus 1, get 3, 4 times 3, boom, I'm done. However, at times you won't be able to add the numbers in parentheses because one might be a variable, and we'll see that shortly. So in your textbook, they have it written out like this. You don't have to copy it, but I just want you to see the different ways that this can be written. Let me make this a little bit larger for my chablitos. All right, so what you're going to see, I need to extend this a little bit. So what you'll see is that when we're looking at the distributive property, we have, hold on, darlings. Yeah, when we're looking at the distributive property, we're basically taking a number outside and you're multiplying it by each of the numbers that are being either added or subtracted. So if they're being added or subtracted, as we can see here, we can multiply the number on the outside by the number on the inside, by the numbers on the inside to get an equivalent expression. And we'll do a couple of examples shortly. I'm getting tongue-tied. All right, let's do some examples now. So as I look at example 1, we're going to evaluate this numerical expression. So here, it says use the distributive property to write the expression as an equivalent expression, then evaluate the expression. So even though we don't have to do it this way, we are being asked to use the distributive property, so we're going to do that. We're going to take 5, we're going to multiply it by 12, then take the 5 and multiply it by 4, and we're going to add up the products that we get. So 5 times 12, I'm going to actually write it out, though we usually don't do this all the time. I'm going to write this in an immediate step. 5 times 12 is 60. And then 5 times 4 is 20. 60 plus 20 is 80, and that's my answer for that, right? If I had taken 12 plus 4, I would have gotten 16. 16 times 5 is 80, so we see that it's a true thing. Here, if you notice that the number that we're multiplying is on the opposite side, but still there's no symbol, no addition, subtraction, multiplication or division symbol, so we know that this is multiplication. And I'm going to multiply 8 by each of these terms. So this is 8 times 20 minus, look at how I'm observing the negative sign, because this is a negative times a positive. This positive 8 is being multiplied by a negative 3. So that's going to be a minus 8 times 3. Does that make sense? I hope so. 8 times 20 is going to give me 160 minus 8 times 3, which is 24. When I subtract 24 from 160, I get, I think, 136. If I'm not mistaken. And I could have probably done this differently. 20 minus 3 is 17. 17 times 8. 8 times 7 is 56. Carry your 5. 8 times 1 is 8. Plus 5 gives me 13, so 136 we get there as well. All right, so the distributive property is going to be demonstrated in places where we don't necessarily have to use it, but we do it anyway just to practice the skill. Let's take a look at this next example here. So it says, use the distributive property on a school visit to Washington, D.C. DeChali and his class visited the Smithsonian Air and Space Museum. Tickets to the IMAX movie cost $8.99. Find the total cost for 20 students to see the IMAX movie. So how would we write this down? How would we do this? Certainly the straightforward way would just be to take 20, multiply it by $8.99, and keep it moving. However, when we have situations where the text is asking us to use the distributive property, oftentimes it's because the multiplication isn't really convenient, and what they're asking us to do is to kind of create a more convenient way to do it. So here's what we could do. We know that we're going to take 20 and we're going to multiply it by $8.99. Is there another way we could write $8.99 a more convenient way? I'm going to use yellow because that seems to work better in this background. So 20 times, how about $9 minus 1 cent? All right, that's pretty easy multiplication. I can multiply 20 times 9. I can multiply 20 times 0.01, which is pretty simple, and I can get my answer and subtract, and that'll be good. So what this is giving me is an easier way around multiplying by a somewhat difficult decimal, 8.99. So 20 times this, and I don't need to write this multiplication there, but 20 times 9 is what I'm going to do, and then I'm going to multiply 20 times this negative 0.01, or this negative 100. So 9 times 20 gives me 180, and then 20 times 0.01 is going to give me 0.2. So now my answer is going to be $180 minus 20 cents. And that is a little easier to do. I don't know about you, but I think it's not too bad. So I end up with $179.80 as the cost of all of the students in T'Challa's class going to see the IMAX movie for $8.99. Make sense? All right. I know it's a little bit forced, but again, we're practicing a new skill, so just go with it. All right. Example 3. Simplify this algebraic expression. So now we're dealing with situations where the distributive property is vital for rewriting. So I've got 4 times x and then 4 times 5. So I'm going to rewrite this expression without parentheses by multiplying through using the distributive property. 4 times x is 4x. 4 times 5 is 20. And so I'm left with 4x plus 20. So this is the same as 4x plus 20. Let's try this one together. So I'm going to multiply the 6 times each term within the parentheses. So I get 6y plus 60. Let's see if we have another example that might be fun to do, or sort of fun, right? All right, so example 4, simplify the expression with subtraction. So I've got 3 times m minus 4. So 3 times a positive m is going to be 3m. 3 times a negative 4 is going to be negative 12, right? Because it's a positive 3 times a negative 12. You with me? All right. So I'm sorry, positive 3 times a negative 4 gives me a negative 12. All right, my bad. So negative 9 times n minus 7. I'm going to multiply negative 9 times 7, and negative 9 times n, and negative 9 times negative 7. And watch, when I multiply negative 9 times n, I get negative 9n. Not surprising. But when I multiply this negative times this negative 7, I end up with a positive 63. All right. So one of the things about distributive property is that you guys really need to make sure you watch your signs. A place where a lot of students fall prey to sloppy mathematics and mistakes is here. Multiply that negative times a positive, you get a negative. Multiply this negative times this negative, you end up with a positive. All right? And that looks like it's it for us for this section. I hope the video wasn't too confusing. Please let me know if you have any questions, and I can't wait to see you in class. Take care. Bye-bye, guys.